We've talked all unit about slope. Slope is the number that is used to describe the steepness and direction of a line. We've already been calculating the slope of linear functions by calling it the rate of change. And all unit long, well, we've used the letter m to represent slope. We've also talked a lot about y-intercept. The y-intercept of a line is the y value of the point where the line intersects the y-axis. We've been already finding the y-intercept of linear function and have been calling it sometimes the initial value. All unit long, we've been using the letter b to represent the y-intercept. Today, you are going to have to find the slope and find the y-intercept from a line. To do that, well, I'm going to give you two examples. So if it asks us to find the slope of line A, all we have to do is find 2 points on the line that are right on the corners. So right now, I'm putting all of these points to show those are directly on the corners. From there, we can count our rate of change. For example, from here it goes up 1 and over 1. So I know the slope for line A is 1 over 1. If we do the same thing for line B, I'll use green for this one, and look at spots that are directly on the corners, hopefully you're noticing these points. These points are directly on the corner this time. Once again, we'll count our rate of change, so we'll go up 3 and over 1. So our slope for line B is 3 over 1. For both of these lines, we'll notice that it starts right here at 0. So our equation would be y equals 1 over 1x plus 0 for line A, and for line B, it would be y equals 3 over 1x plus 0. The word steeper represents something that's going up faster. So hopefully we can recognize that this line here, line B, it's going up faster than line A. I can see that this is steeper. So we know line B is steeper. Another way that we can tell line B is steeper is because its slope is bigger. So we can also say because 3 over 1 is bigger than 1 over 1. We know that line B is steeper. Go ahead and try to do the same thing for line C and line D, and then unpause when you're done and check and see if you did it correctly. For line D, those points are on the corners. For line C, I'm seeing that these points are directly on the corners. For line C, if we count the slope, you'll notice that it's down 2 and over 1. So we could say it's negative 2 over 1. For line D, if we count the slope, well, we'll see we're going up 2 and over 1. So for line D, our slope would be positive 2 over 1. Both equations, again, start at 0. So our equation for the first one would be y equals negative 2x, or negative 2 over 1x. And for our second one, we can write y equals 2x. This time, you might notice the steepness is kind of the same. This one's going kind of up at a certain rate, going up by 2. The other one, though, is going kind of down at the same steepness. It's going down by 2. So we can say that the steepness is the same. But we can say that line C is going down or has a negative slope, while we can say that line D is a positive slope. All right, and we can see those similarities and differences in the numbers. negative 2 over 1 goes down. Positive 2 over 1 goes up. But since they're both 2 over 1, that's why they're going at the same steepness. All right, let's take a look at these graphs. I want you to try on your own to again write the line for slope E, for line F, and for line G. You can pause the video and then unpause to see if you picked and did it correctly. All right, so as you unpaused, hopefully you found these points were ones that were right on the corners. So for slope E, we can go up 3 and over 1, then our slope would be 3 over 1. For line F, if we go up 3 and over 1, again, we'll notice that's the same slope. And also for G, we would go up 3 and over 1. So all three slopes had 3 over 1 as the slope. If we look back at the y-intercepts, where the lines touch the y-axis, for line E, we'll notice that it touches right there at 1, 2, 3, 4. So our y-intercept is 4. For line F, we'll notice that it touches right here at the origin, or at 0. And finally, for line G, we'll notice that it touches right here at negative 3. So all three lines have the same slope. And all three lines have different y-intercepts. Lines with the same slope, well, let's write our equations. This one would be y equals 3x plus 4. We could write 3 over 1, but I'm going to start simplifying and just writing 3x. We also have y equals 3x. And finally, y equals 3x minus 3. I could have written 3x plus 0, but I'm just going to write 3x because it's a little more simplified. So what can we say about all the lines that have the same slope here? Well, they do not touch. Or they don't intersect. Right? If we take a look at these three lines, they're going to keep going on forever. And they're not going to touch each other because they all have the same slope. All right, the last thing we're going to do together is this section right here. So go ahead and try for these four to find the slope and the y-intercept. All right, for our first one, hopefully you found these points were right on the corners. So our slope, we were going up 2 and over 3, and our y-intercept was 0. So for this one, y equals 2/3 x was our final equation. For this one, hopefully you noticed that, well, we weren't moving up at all, but we did move over to the right 1, and our y-intercept was at negative 3. If we wrote our equation, it would be y equals 0 over 1x minus 3. 0 over 1 is the same thing as 0, and 0 times x, well, that's also 0. So if we simplify this, our final equation would be y equals 3. For our third equation here, hopefully you noticed these points were right on the corners. So my slope was negative 3 over 1, and my y-intercept was at positive 2. So our equation for this one was y equals negative 3x plus 2. This last one here was very different. If you notice this time, well, we maybe moved up or down 1, but we didn't move to the left or the right. And this one, there was no y-intercept. It never touches on the y-axis. These kind of lines we call x equals lines. They're the only lines in the world that don't have a y in them. If you have a line going straight up and down, this is something called an undefined slope. So instead of writing 1 over 0, we would actually say the slope of this line is undefined. The equation of the line is, well, where does it touch on the x? It touches at 1, 2, 3, 4. So our actual equation would be x equals 4. I know that's something new And we're not going to have to know anything about this line other than that it's an undefined line. So this is an undefined slope. What about this slope over here? Hopefully you know if we go on the left and kind of look at what's going to happen to the line, we see it's going up. So just to review, this is a positive slope. When we have a line like this that's completely flat, it doesn't go up or go down, this is called a zero slope. And again, if we put our finger on the left on this line, we'll notice, well, the line goes down. So this is an example of a negative slope. Okay, so now that we've reviewed what positive, negative, zero, and undefined slopes look like, I'd like you to go ahead and try writing the equations for these three problems and then moving into our practice online.